Let's explore query execution plans. These plans help us understand and analyze database execution strategies. In the upcoming slides, we'll unravel how databases decide on the most efficient way to retrieve the data that we need. So, what exactly are query execution plans? A query execution plan is a sequence of steps that a database engine uses to retrieve data from a database. Think of it as the database's roadmap for executing your SQL query in the most efficient way possible. When you send a query to the database, it doesn't just blindly search for the answer, instead, it creates a plan. Why are execution plans so important? There are many reasons. First, they allow for performance optimization, allowing one to identify bottlenecks and inefficient operations that slow down query execution. Second, they help in query troubleshooting, which means you can diagnose problematic queries by understanding exactly how the database processes them. Third, they enable resource management, so you can understand resource consumption patterns and optimize database workloads accordingly. Let's discuss the key components of execution plans. First, there are the operators, which are the individual actions performed by the database engine, such as scans, joins, and sorts. Then there are cost estimates, which are relative resource consumption metrics for each operation. Additionally, there are row estimates, which are the predicted number of rows processed at each step. Finally, there is execution order, which is the sequence in which operations are performed. Let's take a look at common execution plan operators. First, there's the table scan. It reads all rows from a table sequentially, which can be expensive for large tables. Next, there is the index scan, which uses an index to find specific rows, and is typically more efficient than table scans. Then there's the hash join, which builds a hash table from one table and probes it with rows from another table. After that, there's the nested loop join. For each row in the outer table, it scans the inner table for matches. Then we have sort, which orders rows based on specified columns and is often used for order by clauses, and finally aggregate, which performs calculations across rows such as count, sum, and AVG. Now let's understand how to read execution plans. First, identify the execution order. Plans execute from bottom to top and inside to outside. The innermost and lowest operations run first. Second, analyze cost values. Look for operations with high costs, as these are potential bottlenecks in your query execution. Third, check row estimates. Large discrepancies between estimated and actual rows can indicate outdated statistics. Finally, examine access methods. Table scans on large tables are usually inefficient. Look for index usage opportunities. Let's explore optimization techniques based on execution plans. The first technique is indexing strategies. Create appropriate indexes for columns used in where clauses, join conditions, and order by statements. The second technique is query rewriting. Restructure queries to use more efficient patterns and avoid expensive operations. The third technique is statistics management. Keep database statistics up to date to help the optimizer make better decisions. The fourth technique is join optimization. Ensure joins use appropriate algorithms and join smaller tables first when possible. Let's analyze a case study. The problem is that a query that retrieves customer orders is taking over 30 seconds to execute on a database with millions of records. The execution plan analysis revealed two key issues. First, a full table scan on the orders table, and second, an expensive sort operation for order by. The solution was to first create a composite index on the orders table, and then update statistics to help the optimizer. As a result, the new execution plan shows an index scan instead of a table scan, and no separate sort operation is needed. The query execution time was reduced from 30 seconds to 0.5 seconds. Here are some best practices for query execution plans. First, implement regular monitoring. Periodically review execution plans for critical queries to catch performance regressions early. Second, test before production. Analyze execution plans in development and staging environments before deploying to production. Third, maintain statistics, keeping database statistics up to date, especially after large data changes or schema modifications. Fourth, document findings. Keep records of execution plan analyses and optimizations for future reference and knowledge sharing. Fifth, use visualization tools, leveraging database-specific tools that provide visual representations of execution plans for easier analysis. Query execution plans are powerful diagnostic tools that provide insights into how databases process your queries. Mastering their interpretation is essential for building high-performance database applications. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.